Welcome everyone, thank you for joining me. I'm here to introduce a project I've been working on for quite some time now. And I must apologize for the state of this. I have attempted to record this the somewhat professional way with a list of notes that detail the steps I want to go through in order to properly and clearly communicate what I want to say. But it appears that I am yet again utterly incapable of doing so. So instead, I'll do it the way I generally approach these things, which is with a rough plan in the back of my mind, and I'll just wing the rest of it. It shouldn't come as a surprise to any of you who know me personally or who have attended a talk by myself anyways. So what am I here to talk about? Vapour. A Vapour is a typed superset of the R programming language. The idea is that we take R, we spice up the language a bit with some types, and this allows us to output R code that is slightly less error prone, thereby making you a tad more confident in the code you produce. Now, I'll jump into an editor and write some code to give you a taste of the language. But before I do so, in the event that you want to follow along, you can go to vapour.run and you can go to install the language. If you've got Go, it's as easy as pie. Just run that. Otherwise, it's fine too. There are pre-built binaries for pretty much all operating systems. All flavors of Linux are covered, Mac, and you'll find an executable for Windows. However, this is only half the battle, because this being a new programming language, your editor won't understand it. I'm doing air quotes. That is, there will be no LSP to help you, nor will you have any syntax highlighting. So what you want to do after that is head over to the editor tab and set up your editor. Currently, I support Vim. NeoVim is marked as coming soon because I am fighting a losing battle against Lua. If you're watching this and you understand Lua, please do get in touch. Could be some help there. And finally, there is VS Code. There's an extension for it, so you can install it just like you would any other extension. And this will give you the syntax highlighting as well as the LSPs. Note that the LSP focuses on, well, doesn't focus on, it pretty much only does diagnostics. I don't have auto completion or anything of that sort. So with that done, we can jump into an editor. So here I'm in my terminal. I've got another session here with R running 4.4.1, not that it matters. And the idea is that we create a small R package. So I'm gonna use R for this, use this package to create a package that's gonna be called Vapour. Now I can move into that directory like so, and if we see what we have in there, so it creates a box standard skeleton of an R package. There is a description file, a namespace file, and normally an empty R directory indeed. So I have a convenience little package here to scaffold your project. That is, now we're not gonna write R code, obviously we're gonna write Vapour code. It needs just a handful of things. You really don't need a package. Let me show you what it did. So it created the inst directory that's standard for an R package, and it created a VP directory. That's where our Vapour code will go. It also added a VP directory to the R build ignore, so that the RCMD check doesn't complain when you check your code. So with this, we're ready to start. So what I'm going to do is create a file in that VP directory. I'll name it vapour.vp. .vp is the file extension that the programming language expects. With that file created, I can now open it like so, and we're inside Vapour. Now, the very first thing we can do, because it differs a bit from R, is simply creating a variable. So in R, you could do something like x is equal to 1. In Vapour, it works a bit differently because you have to declare your variables. You can't just create them on the fly. I'll get into why in a minute. So we start with a keyword let that allows you to declare a mutable variable. After let, we have the name of our variable, and then the types start kicking in. So the way you declare a type is going to be with the always starting with the colon. So we start with a colon and we follow it by the name of our type. So in R here, I created an integer technically, or I think technically actually it's a numeric. But let's assume I type this and I got an integer, and we're going to declare an integer with a keyword int. And then I just assign it the value of 1. Note the assignment in Vapour is the equal sign. The arrow operator thing is used for something else. So now we've declared the x variable, and you can use this x variable. If you want the x variable to now be equals to 2, you can. So you might be wondering here maybe what happens if x is now equals to NA, for instance. Well, we get our first error. And this error, you get it if you've set up your editor. DLSP will let you know that we have an error on the equal assignment, that the left expects an integer, but the right returns NA. The way you handle this is in your types, you can actually specify multiple types with the OR sign, the vertical bar. You can indicate that X might be an NA, or might be an int or an NA. And now the error is gone. Similarly, if now x is equals to null, we'll get an error again, but not to worry, we can just type this and the error goes away. So that's the reason for the types, if you like. The reason for declaring a variable is that now we can better check for the existence of variables in your code. So if I print y was never declared, so I'm being told that it doesn't exist, it's not found. Another reason is, well, this is a dumbed down example, obviously, but if you have a large code base, you might forget about x, and later on you say, well, say this time x is a numeric, I use the keyword num, and is equals to 1.1. Again, we are being told that the variable x is already declared. These are a few reasons. Another one is that now we have another keyword to declare an immutable variable. With const, we declare a constant. So this time x is going to be a constant, and to switch things up a bit, I'm going to make it a character. It could have been a string keyword, but in R we tend to refer to them as characters, so I used char. So x is equals to hello, but because it's a constant, if I now want to assign it something else or reassign it, I'm getting the error that x is a constant. So before I do that, before I move on with my idea, which is to build a small package-ish, with just 1 or 2 functions, I can show you what happens when you get the error. So right now we have only been writing Vapour code. Ultimately, you can't do anything with Vapour code. You need the R code that it produces. If I go back to my terminal, I can transpile that code from Vapour to R with Vapour if you've installed the language, and indicate the directory in which the files are with indir, and I pass it the name of my directory. You can also specify the out directory like so, but there's no need for it here because that's the default. The default directory is the R directory. But we'll see what happens when I do that. I get an error. You get the error that x is a constant in my Vapour file on line 2 character 1, yeah, and I get clearly told that the files didn't transpile. So if I look at my R directory, it is still empty. We'll fix all of that. Well, not really. We'll move on to the example that I want to go through with you, but that's the idea. So if you have an error in your code, you just can't produce the R code. You need to fix this error in Vapour, and then you'll be able to transpile the code. Right. So imagine this, if you will. You've got a large code base that has this concept of a user. Maybe you fetch users from a database, you do plenty of stuff with users in different places for an application or a set of scripts, or you're modeling. So you have this concept of a user. And the idea here with Vapour, if you had that, you'd probably create a custom type that describes what a user is. So you'll have the user, the type that is what the user is and its attributes, and then on it we'll put methods that describe the behavior, if you like, of the user, or the things we can execute on the user. So the way you define a custom type is with a type keyword. What's expected after is the name of your custom type, in this case a user. And after that, what follows with the colon is not really a type, it's a structure, if you like. So here we're not going to define something like an integer or a numeric. We want an object to hold values. So I'm going to use here the object struct, if you like. And I'm getting an error. We'll get to that in a minute. What I want to do first is jump to R to show you what an object is. In R, you can define a list like so. You can have you can mix the types in a list, unlike a vector. So that works. You can have a list like so, which we generally refer to as a named list. And then you can have this absolute abomination where you can mix it all up as you prefer. And that to me is run on so many levels. In fact, I don't think I'm pretty confident it's a structure that you cannot reproduce in many other languages. It just doesn't exist. It's unclear whether it's an object or an array. It's unclear whether you can even iterate over it. If you're an R user, you might be confident with this, but it's certainly not standard. And to demonstrate, if I attempt to convert that to JSON using JSONLite, I get the following. So the first element in our list seems correct, x equals to 2, but the second you see that JSONLite has to, well, make a decision and it has to name it. And so now it produced actually an object within curly braces and not a list that you would kind of expect. So that's what an object is. An object is just a named list. To give you an idea, in here you could have different kind of structure, a matrix, you could have a data frame, you could have, well, an actual list, which would be unnamed, and there are others. But what we want here is an object, and I think generally that's what you can do, probably 99% of the object. So what attributes will our user have? I suggest you should only have 2 for the sake of simplicity. We'll give him or her, a unique ID and a name which will be a character string. And now I have my custom type created. What I want to do next is create a function that instantiates this new type that we have created. The way we're going to do this is by writing our first function, which differs quite a bit from R. In Vapour, function declaration is very much nicked again from Go. So you start with a func keyword. And there's a good reason for that. I hope I'll remember to share it with you, but there's a good reason why we changed the function declaration. So after func, we expect the name of the function, which will be, I don't know, create, because we want to create a new user. And say when we create a new user, we're going to give it, we must give it an ID. So we have an argument ID. Again, after that, I want the type to follow. So my ID has to be an integer. And after the closing parent there, I want to indicate the return type of my function. I'm going to do that with a colon. Like we said, we have this function that's now going to return our custom type, user. I can type user and enter the body of my function. Now, how do you now instantiate an object, a user object? Well, essentially, the type user that I've declared on line 1 in Vapour becomes a function. So I can call user like so, and pass it the ID. So I'm going to put ID equals ID. Now I'm going to save the file. We're going to see a few errors on screen, and we'll go through them together. The first one that we see is create is missing return. Indeed, in Vapour, the return keyword is mandatory. I think it makes code vastly more readable, and it makes it much clearer what a function returns. So we use the return keyword like so. Save, we have one error, but the second is still there. ID might be missing. Indeed, we declare, well, yeah, we have this argument ID, but it can indeed be missing. If I jump to R for a second, say we have created this function foo that takes argument X and just add 1 to it, we can call foo with 41 and obtain 42 and think everything is all good. And you share this function with the community and they called it like this. And it errors because indeed argument X is missing. So this is a check to make sure that that you don't overlook these kind of issues. So how can I fix it? Well, I could give it a default value, maybe, like so. But it's probably not appropriate for what we're trying to do. But indeed, now that I have a default value, ID can no longer be missing. Similarly, if I did that here, and then I'll go through like I did before, it no longer errors. However, like I said, I don't think it would make sense in this instance to have a default ID if we want them to be unique. So what I can do instead is simply check that it's missing, or not missing rather. And like so, you'll notice that the error is gone. Now we have our function to instantiate this new user object, on which I might see a tad more actually. We had the user object has two attributes, ID and name, which we can, now that it's a function within our Vapour code, we can check on the type of this. So if I accidentally or forget and I type something like this, I get that the attribute ID expects to be an int and not a character. Similarly, if I now want to pass the name and I pass the name like so, I will also get an error because here I pretended to make a typo and the attribute NNE does indeed not exist on that object. So it allows us to be a bit more strict in this regard. But now that we have our function and instantiates a new user, we can create our first method. And since we already set the ID when we instantiate user, what we can do now is maybe a method on the user object to give it a name. And the way you declare a method here is with a func keyword. And you follow it not by the name of the method as you might expect, but by the object on which you're going to dispatch the method. So I'm going to have the method dispatch on X, which here I expect to be of type user. And then after that, I have the name of my method, which is going to be set name. The method is going to take a name, of course, which is going to be a character, and it's going to, if I can type it, return return a user. The idea behind this is because it's something that I'm still very confused about in R. It is that you define a function, you define a generic like so. You'd have something like x and then use method x. But then you define the method with the dot. So who dot user in our case, function x, and so on. But the problem is that R allows dots in the names of functions and identifiers, and therefore you can end up with something like foo dot something dot data dot frame, and here it's actually very confusing what the method is on. You don't know if it's foo's got a method on data dot frame or foo dot data has got a method on frame. Might seem like an exaggeration, but it causes a lot of issues in plenty of places. Although I believe that R does a pretty good job of dispatching the right method, it's not something I want to deal with here, and that's the main reason for changing the way you define a function in Vapour and not to take how it was in R. So I have this method now on the object X, which we expect to be a user here. So I can do it just like I would in R. X $name is equals to the name, and then I can return like so. We'll get the error again. Name might be missing, and I'm gonna default it to John like so. And that's our first method. Now this is method that's going to be converted to R code, if you like. So if you know how that works in R packages, you have to export it. And one thing we're missing is a generic. You can define the generic like I did in R just now, or you can do it in Vapour with the @generic decorator. This is a decorator that expects afterwards a function definition. So I'm gonna have this. Well, I can type what I might expect people to type, and we'll see the error again. So it's going to dispatch on X. It's going to be a generic set name. It expects a name, and it's going to return read. And if I do that, I see that the generic must be on method any. Indeed, if I look at, if you think of it, you don't know the type that a generic is going to have to accept. Essentially, it's anything, and that's what any is. If I go to the very bottom of my code here and make some room, if I do let x equals int like I did before, then x is equals to hello, I get an error, obviously, because x is expected to be an int. But if I put it as any, it accepts anything, literally anything. X can then be NA, it can be whatever I want it to be. And that's what this type is for. Please try and use it as little as possible, because it defeats the purpose of a type programming language. Another one that I'm still unclear about is the return. I think it should be any. I don't have a check on that yet, but I think it should be an any, because you don't know what the generic is going to return. And like so, I think we have our first little R program. What we can then do is go back to the terminal, transpile the code. This time it works fine. We get told that the files were successfully transpiled. Let's see if I take a look at the R directory, I see that I have a file called vapour.r. And now if I go into R, I'm going to document, because I have S3 methods that need to be documented for them to work. And then I can load all, and we can use our package. So I'm going to have a user John, which is going to use the function create, which we created in Vapour. Remember, we have stop if not check on the ID, and we do indeed see that it kicks in. So I'm gonna have here, John's gonna have the ID of 1, and then we can pipe this object to our method set name, where I can put name is equals to John. Well, just because this was our default, I'm gonna change it to Jane, like so. And you can see the object that's returned, which is our user object. So it is a list, as you can see. It's got an ID and the name that we define, and our type becomes the first class in our R code, essentially. But because we use the object type, it would inherit from list. Yeah, I think that's what I have for you today. You feel free to, well, I hope you do give this a go and give us feedback as to what you think of the language. Thank you.